Did you know that the two different subtypes of calcium oxalate stones can get together and make mixed monstrosities? Well, if you're forming calcium oxalate kidney stones, you're going to want to familiarize yourself with this information. Hi, I'm Joey Weichman, and welcome to Stone Relief. Calcium oxalate kidney stones are one of the most complicated stone types. With two different subtypes and several different variations of each subtype, things get messy quick. To make matters worse, they oftentimes intermingle with each other, forming mixed stone types, which then make identification and prevention even more confusing. So today, we're going to run through a few of the most common examples of mixed calcium oxalate stones to help you better understand what to look for once you pass your stone, to help you in your quest to prevent future kidney stones. So, what are mixed kidney stones? Let's dig into it. So, when it comes to the calcium side of things, calcium oxalate monohydrate, also abbreviated as COM, C-O-M, and calcium oxalate dihydrate, C-O-D, can form together. And as we'll talk about, there's some different things that are happening in the body that are kind of leading this swing from calcium oxalate monohydrate to calcium oxalate dihydrate. So, calcium oxalate monohydrate, or COM as we've abbreviated here, is the most common stone type. And the COD is calcium oxalate dihydrate, and it is much less common than this. The COM stone type is about like 80% of the stones out there, and the COD stone type is somewhere in the neighborhood of maybe 5 to 10%. It's relatively low. So the difference between these two stones really comes down to the water to the calcium oxalate molecule ratio. So when it comes to calcium oxalate monohydrate stones, and if you've watched our previous video that goes into real deep detail about these stone types, you know that calcium oxalate monohydrate stones are more dense than their calcium oxalate dihydrate, brother or sister rather. And that is because, again, due to the water to the calcium oxalate molecule ratio. So with calcium oxalate monohydrate stones, again, monohydrate, there is a 1-to-1 ratio of water to the calcium oxalate ion or molecule. And this means that they are more tightly bound, and it is a more dense stone type, which makes it more difficult to break apart. Whereas with calcium oxalate dihydrate or COD stones, there's a 2-to-1 ratio of water to calcium oxalate. Again, di-2, dihydrate, 2-hydrate, monohydrate, 1-hydrate. All has to do with this water to calcium oxalate molecule ratio. So when you've got more space, there's there's more opportunity for things to be able to kind of get shuffled around and break apart those stones. That's why COD stones or calcium oxalate dihydrate stones are considered weak. So why do these mixed stone types form? Well, really it has to do with the increase and decrease of calcium levels with regards to hyperoxaluria. So calcium levels on their own do not form any risk or pose any risk for kidney stones. However, when you've got varying degrees of hyperoxaluria, meaning there's more oxalate or lower oxalate, just kind of weaving in and out of your body, this is where these stone types really start to form. And they look like they're combinations. So this stone type here is very similar to, as we'll talk about in a second, the most common calcium oxalate dihydrate stone, which is kind of spiky and also has some common elements of the most common calcium oxalate monohydrate stone as well. It's circular shape and its inside. Now we're going to dive into these stone types in more detail in the next chapters here, but just on the surface, if you're looking at these should tell you something because they look different than most of the other stones, which is again a telltale sign that something funky's going on, and they've likely intermingled again due to this varying degree of calcium levels in your body when combined with varying degrees of oxalate present as well. So in the next chapter, we're going to dig into this first guy, which is typically the most common type of mixed stone that people see. All right, so I want to introduce you to the type 2A/1A/2B mixed calcium oxalate kidney stone. That's what these things getting together represent right here. That's kind of the combination of things that occur. Now, when we're looking at these things, we're talking about really kind of surface level, and then there's the interior organization of the stone. So surface level is very reminiscent of the 2A stone, which is a calcium oxalate dihydrate stone. And then the interior organization of it is calcium oxalate monohydrate stone, and then also a calcium oxalate dihydrate stone as well. So it's kind of like a mishmash, and there is no perfect combination. There is no super clean, yours is going to look exactly like this. It just doesn't exist. So again, we're showing like general shapes here to give you an idea of what things are going to look like to the best of the ability. Because again, the body is going to do a whole bunch of weird stuff, and these stones are going to look very, very different probably than what you see here. They might look like vaguely familiar, but more often than not, it's going to be a little bit different. So again, you've got to take this with a grain of salt. But this stone type in particular represents this round shape, and again, that kind of lends itself to the calcium oxalate monohydrate type 1A type of stone that we talked about in previous videos. And the cauliflower surface, and that surface, again, we're talking over here, it's a calcium oxalate dihydrate type A stone. So most common type of dihydrate stone, you can kind of see similarities to the surface structure due to that dihydrate stone contributing. So their coloration is typically like a white color to a slight yellow, slight light brown, and this is due to the pigmentation in your urine. And the cause of this particular stone type, just like most of the, just with like every other calcium oxalate stone type that's out there, is secondary hyperoxaluria, meaning diet. Whereas primary hyperoxaluria means that there's a malfunction with our liver and we're producing oxalate ourselves, which is feeding kidney stone formation, which is super rare. 1 person in 3 million. Damn near unicorn status. So not what we're talking about here. Secondary hyperoxaluria is equal to diet. Now, contributors to this as well. So as we had talked about in the previous video about calcium oxalate dihydrate stones, this 2A stone really kind of associates itself with increasing and decreasing calcium levels, but really kind of more of an elevated level of calcium, hypercalciuria. That is really what dictates this type of stone formation versus the type 1A stone formation. So hypercalciuria means elevated levels of calcium in the blood. So this is kind of what we're seeing here in terms of the physical manifestation, and then those varying levels that you see of calcium is going to be a contributor to the, again, percentage of a monohydrate stone or percentage of a dihydrate stone. Next chapter, we're going to take a look at another stone type that is mixed with, yet again, another dihydrate and monohydrate combination, which is the second most common type of mixed stone that you might see.
Just a reminder, this information is available in written form on our website. Find the link below in the description.
All right, welcome back. So now we're going to be taking a look at the type 1A/2A and 1B/2B. So literally like a mutt of calcium oxalate monohydrate and calcium oxalate dihydrate. Damn near perfect. So this stone type, again, is, a marriage of these different varieties. So we have the monohydrate type 1A, dihydrate type 2A, we have a monohydrate type 2B, and the dihydrate type 2B. So these stone types, again, this is the surface. So again, we're seeing a little bit of the spikiness and kind of that budding that you see on a monohydrate type of stones. And then from an interior perspective, we get to see a little bit of the shape here, which is more common with this type 2B monohydrate stone. And then some of the interior organization is going to kind of lend itself to this 2B dihydrate stone. Now, again, we talked about the shape being driven by some of those other stone types that are kind of like the parent stone types, if you will, to this mixed stone type. Now, the yellowish brown and the dark spots that we're going to observe on here are telling us something. So this kind of like light brown area over here, this is typically indicative of calcium oxalate dihydrate crystals, which are weak. And the darker spots that you see here, and likely the interior of this stone, is going to be calcium oxalate monohydrate, which is much more dense and also darker, just because there's a intermittent fluctuation of active on again, off again type of crystallization that is occurring with monohydrate type of stones that really kind of captures the urea pigment and makes it much more darker than it would be with a calcium oxalate dihydrate stone like this type here, which is typically yellow, not quite clear because there are some little bit of like urea pigmentation in it, but generally lighter than the monohydrate stone type. Now, just like with this previous stone type, just like all the other calcium oxalate stones, diet is the root cause of this. However, there are some contributors to this as well. So just like the previous stone we looked at, the alternating levels of calcium, which is hypercalciuria when it gets high, that is going to be a primary driver for the dihydrate pieces of this, because when calcium levels are high, you typically form dihydrate versions of calcium oxalate monohydrate stones. Now, low diuresis also plays a role in this, and you'll see that if you've watched our videos previous to this about calcium oxalate stones and calcium oxalate dihydrate stones and the monohydrate stones, we talk about in more detail the specific things that can lead to this. But low diuresis in particular, which is low urine volume, lends itself to some of the shape and the format of this particular stone type. So if you're not drinking enough, not passing enough urine, this is likely a contributor in addition to your poor dietary choices that are leading to this stone type. And then lastly, this stone again is typically seen in moderate to high oxalate concentration. So that means that you're eating moderate to high levels of oxalate on a relatively consistent basis versus a lower level, which will show a different type of stone display or presentation, if you will. So moderate to high levels of oxalate concentration are what you will see manifest with this particular stone type when you have varying levels of calcium, which will dictate the switch between monohydrate and dihydrate. Stick around for the last chapter. We'll take a look at one of the more little uncommon stone types, but it has some particular contributors that you'll want to pay attention to. Okay, last but not least is the stone type we're going to take a look at that is just kind of very, very unique looking. And again, that's going to have a very different physical manifestation in your body and what you pass, but there are going to be some telltale signs that we're going to take a look at that will really kind of easily point this stone out to you. So technical classification for this is a type 1A/2B and a 1A surface. So now, I haven't included that 1A stone in here twice, but really this 1A and the 2B type of stone, they're relatively similar in shape. They have different drivers behind them, but this is going to be kind of the surface contributor, if you will. You can kind of see the spiky nature to this. And this is going to be more of the interior contributor, which is the monohydrate type of stone. And that is what you see right here. And it's very, very curious because as you can see here, this has been attached to one of those renal papilla that we've talked about in previous videos, and you can obviously see that it's become detached. So there's a very, very obvious expression of monohydrate, and then a very, very distinct departure from monohydrate to calcium oxalate dihydrate, which is very, very curious. So as we had talked about in the previous videos, the coloration differences you've seen, again, monohydrate, dihydrate, all that kind of stuff here. The spiky surface is associated with calcium oxalate dihydrate stones, and more smooth nubule type of surface is more the monohydrate stone. But again, we're talking about diet. These are just as a baseline for calcium oxalate stones. Inappropriate consumption of oxalate containing foods is what leads to this based on our ancestral lineage and our inability to process that plant toxin oxalate. But there are also some things contributing to this that give this stone its unique shape that are going to be should be shouting from a mountaintop to you to try to take a look at some things to change with regards to your diet and potentially your lifestyle. So the first thing is vitamin D sensitivity. And especially during the winter months that we're in right now when this video is going to be published, vitamin D supplementation is relatively high because sunlight is low, especially in northern latitudes. So people take vitamin D to try to kind of balance things out. And that can be problematic because vitamin D has the ability to kind of generate calcium oxalate stones in particular, when it passes a certain level. And this is a telltale sign of this particular stone type when you have a vitamin D consumption that is out of balance of what you would normally consume through foods without supplementation and get from the environment, mostly coming from the sun. Just like the other ones, the varying degrees of calcium levels, again, this dictates that transition from monohydrate to dihydrate that's present with all these mixed stone types. Low diuresis, again, is also a consistent factor when it comes to calcium oxalate stones because the more that time that you're giving calcium and oxalate to mingle in your kidney, more opportunity it has to form. So low passage of urine provides more time and thus more risk for kidney stones. And then lastly, this stone type is indicative of high oxalate concentrations in your diet. So we talked about the previous stone, which is kind of like moderate to high, and now we're looking at this and that as a higher concentration of oxalate. And I think that really kind of has to lend itself to this really solid core of this monohydrate stone, which is more dense, attaching itself to the pyramidal structure. It's also called the papilla of the kidney, which is really kind of where Randall's plaque is kind of forming, and that's where crystallization kicks off if you've watched our video on Randall's plaque. But nevertheless, that is what is occurring and what you're seeing right here, and that's predominantly driven, again, by vitamin D type of sensitivity issues, the variance in calcium levels. You'll also have the low diuresis, but again, high oxalate consumption. And I just want to drive this home to you guys again, because if you're forming these kidney stone types or any of these mixed calcium oxalate type of kidney stones, it's due to diet choices, inappropriate diet choices in particular. And I know that this can be an exceptionally confusing road to go down. I can't tell you, I probably spent 5 years going down the absolute wrong path and still getting kidney stones at the advice of my doctor and urologist until I figured out on my own what I needed to do in order to put an end to my kidney stones. So if you're curious to know what I know and would like to put a plan in place in order to prevent your calcium oxalate kidney stones, hop onto our website, click the coaching button in the upper menu, and book a call with me, and we'll put a plan together to be able to get your life back and stop your kidney stones for once and all.
Visit our website if you'd like to join a community of people learning to manage their kidney stones naturally. See you in the next video.